A customer chooses June 28th. The server saves June 28th. Their browser shows June 27th. The saved text never changed. This line gave it a time. The date constructor treated June 28th as midnight UTC. Los Angeles is 7 hours behind, so it moved into June 27th. Here is the rule. A calendar date is a day. A JavaScript date represents a moment. We mix them. Now let us fix each case. Started the form. An HTML date input gives JavaScript a string. Our string is 2026-06-28. It contains a year, month, and day. It contains no clock time. It contains no time zone offset. The server stores that exact date-only value. Nothing has moved yet. The change begins in the display code. It calls new date with that string. The JavaScript parsing rule now makes a hidden choice. A date-only string means midnight in UTC. So the date holds one exact moment, the first instant of June 28th in UTC. On this June date, Los Angeles is 7 hours behind UTC. Move that moment back 7 hours. The local clock says 5 p.m. on June 27th. Then the formatter asks for the local calendar date. It correctly answers June 27th. The form was correct, the server was correct, the display code changed the kind of data. A birthday answers one question. Which calendar day? It does not identify one worldwide moment. June 28th lasts many hours across the earth. An instant answers a different question. It identifies one exact point on the global timeline. A JavaScript date stores an instant as a number. It does not store the original time zone. Local methods interpret that instant using the machine's zone. UTC methods interpret it using UTC. The same instant can be June 27th in Los Angeles and June 28th in London. That is useful for a payment time or a log entry. It is wrong for a birthday with no clock. JavaScript did not forget a day. Our code turned a day into a moment. The fastest patch is often add one day. That makes this Los Angeles example display June 28th. In UTC, it displays June 29th. The patch uses one wrong result to cancel another. It cannot be a data model. Another patch appends midnight without a zone. That string is interpreted in the machine's local zone. In Los Angeles, it becomes 7 a.m. in UTC. On a UTC server, it becomes midnight UTC. The same text now creates two different instances. The visible date improved, but the meaning became unstable. Hard coding 7 hours also fails. Los Angeles uses an 8-hour offset during part of the year. Choosing noon instead of midnight only moves the boundary. It still invents a moment the customer never supplied. Do not patch the clock until the date looks right. Fix the type of value. For a birthday, keep the value as 2026-06-28. Validate it at the system boundary. Then keep it as a date-only string or 3 named fields. The names matter. Call it birth date, not birth timestamp or created at. In a database, use a date-only column when the domain means one calendar day. In JavaScript, you can split the validated string into year, month, and day. Format those date parts without silently converting them into a local instant. A date-only library or type can handle calendar rules and localization. Temporal plain date fits this model. Temporal is not available in every major browser yet. Check support or use a maintained polyfill. The important rule survives every library choice. A plain date stays plain until a real time and zone exist. Now, consider a payment created at 2 p.m. UTC, that is, an instant. Its value should include the time and an offset, such as a final Z for UTC. 2026-06-28 T14 colon 00 colon 00 Z identifies one exact moment. A JavaScript date is appropriate here. Display that instant with an explicit target zone. Los Angeles sees 7 a.m. Dhaka sees 8 p.m. Different clocks are correct because the moment is the same. A future appointment needs one more piece. 9 a.m. in Los Angeles depends on Los Angeles time zone rules. Keep the local date, local time, and zone name together. Then resolve them to an instant when needed. An offset like -7 is not a complete zone. Daylight saving rules can change the offset. So we have three boxes: plain date, exact instant, scheduled local time with a zone. Choose the box before choosing the JavaScript class. When a date moves, print the row input first. Do not start with the formatted label. Then print to ISO string. It shows the exact instant your date contains. Print to string 2. It shows how the current machine interprets that instant locally. Finally, test more than one zone. Run the same case in UTC and Los Angeles. Ask 4 questions. Did the user supply a day or a moment? Where did the time get added? Which zone did the parser assume? Which zone did the formatter use? If any answer is accidental, the bug is waiting for another machine. Return to our profile form. The customer chooses June 28th. The server stores 2026-06-28 as a plain date. The browser displays June 28th. No day was added. No offset was guessed. The value never became an instant. A date is not broken because two places show different days. The model is broken when one value means both a day and a moment. Name the promise first, then choose the type that keeps it.